Okay, so our first question here, you can see where it's taken from. It's an IEB paper. Please don't get scared by IEB papers. They really aren't harder. The order of the questions is different. Sometimes questions are asked a little bit differently, but it's the same content. Okay, so don't be scared to look at them. They are still good to look at, especially if you do just want to see how questions can be asked slightly differently to what you're used to. All right. So it also helps if I can do English, but whatever. So it says if cos 25 equals m, then without the use of a calculator, determine the value or values of the following in terms of m. All right, so we spoke about this type of question on Monday, and we spoke about the fact that even if it doesn't tell you, draw a diagram that expresses or that shows all of the information that you have here and kind of puts it all into one place for you. So what I want you guys to do for me is I would like you to draw the diagram that expresses the cos 25 equals m situation. If you feel super comfortable to go and answer these questions, that's great. But I would like just the diagram to start off with, and then we will go from there. So I'll give you 2 minutes to get your diagram, and then we'll have a look from there. Kanye, they don't necessarily mark the diagram. Once we've choose my brain. Once we've drawn the diagram, I'll tell you what part of it we do mark. We mark the Pythagoras portion. So we don't mark the diagram. So you don't have to draw it. But it is very useful to draw because as we saw on Monday, it gives us an idea in terms of what angles we have available to us. Excuse me, which could potentially lead us to co-ratio questions. And generally speaking, they always throw a co-ratio question at us and a double angle question. So you don't have to draw the diagram, but it is super useful. Right, so guys, like I say, 2 minutes and then we'll have a look. Alrighty. Right, so again, guys, the diagram is not a must, but it really is helpful. Personally, I will never do a question like this without a diagram. Same as like Cartesian plane questions, I'll never do one without a diagram. Particularly if you are a more visual learner, it is nice to have a diagram. But again, you find what you're comfortable with, particularly in sections that are notoriously trickier, like trig or even Euclidean geometry, which we will talk about next week. Okay, so diagram. It's an acute angle that we're working with, so we can draw a right angle triangle. We have our 25 degrees, and what that means is that the third angle of my triangle I can find by just finding sum of angles in the triangle. I'm realizing that this is teeny tiny on the screen. Okay, there we go. All right, so we can just use sum of angles in a triangle, and we get that our other angle here is 65 degrees. I like to draw the triangle, particularly because I struggle a little bit with co-ratios. My brain doesn't see them as easily. And so when it does come to co-ratios, if, say, for example, I'd given you a question here of like, I don't know, cos 65 degrees, the expectation is that you use a co-ratio. However, if you've drawn the diagram and you have all the information, you can then just go straight to reading off the ratio. So for me, particularly with co-ratio questions, I like a diagram because my brain doesn't automatically go to co-ratios. Can't tell you why. I just know that for me, that's a weakness I have when it comes to trig. And so I use this method to try and help myself. All right, next thing is we know that cos 25 is equal to m. Now remember, this is the ratio that we have. Cos is adjacent over hypotenuse. And because it's equal to m, that we can write as m over 1. So the adjacent side to the angle 25 is m, the hypotenuse is 1. And using Pythagoras, we can get our unknown side here. So I'm going to call that y, just because it's a vertical line. Y squared would be equal to 1 squared minus m squared. And so coming back to your question, this is what we would mark, the Pythagoras calculation. And so we get that y is equal to the square root of 1 minus m squared. Remember, grade 12s, again, I said this on Monday, we don't take the square root of 1 and the square root of m. They're two separate terms underneath my square root. I have to leave it there. If it was 4m squared being square rooted, then yeah, absolutely, 2m. But because it's two separate terms, we cannot square root individual terms. We're square rooting the whole value of that expression, so I leave it there. And so now I know that this value here is square root 1 minus m squared. I don't need to see your substitution into Pythag. You can go straight to y equals root 1 minus m squared and just have Pythag there. But that is where we do mark you in terms of the diagram or in terms of additional information that you need. Lorato? Lorato?
Hi, ma'am. Can you hear me?
Hi. Yes.
Ma'am, so the Pythag in brackets, do we have to show it? Or could it be like in the case whereby we just forget to add it on the side, but you can see the y squared equals to 1 squared minus m squared, and then the final answer, we still get a mark?
It's not the end of the world if you don't write it. Technically, you should because it is a geometric reason, but it's not the end of the world if you don't show it. Okay. Alrighty, guys. So now we have our triangle. That's beautiful. Now we can go and find our ratio. So 1 minute, find the ratio of sine 25 for me. Right, so all we do now, literally just read off our diagram, sine 25, opposite over hypotenuse, so 1 minus m squared. Yes, it's technically over 1, but remember, that doesn't change anything, so we just leave it like that. All right, so now when we get to our next question. So usually the first question is a nice, easy, just read it off your diagram. But from there on out, as I've already said, we need to be mindful of compound angles and double angles. As well as co-ratios. So if we look at question 2, it's cos of 50. So bearing all of that in mind, I want you to try and work out what the ratio of cos of 50 is. So again, bear in mind compound angles, double angles, co-ratios. I want the ratio for cos 50. Don't panic, I am coming back to it. I just want to grab our trig formula sheet. Okay, so guys, just bear in mind when I say 2 minutes is according to the mark allocation. So while you're studying, you should be using that as like a time management tool as well. All right, so cos 50. First thing I always check, is it an angle in my triangle? Because if it is, then I read off the ratio. It is not an angle in my triangle. My angles are 65 and 25. So now I need to go and check compound, double, co-ratios. Now we can clearly see that if we double the angle we have, 25 degrees, I will get 50. So we're working with a double angle situation. Okay, now remember your cos double angles, you have got 3 options. Now it doesn't matter which one you choose to use. We will mark all of them, so it really doesn't matter. But use logic. Okay, so what I mean by that is use the one that's going to simplify your life most. We have already seen that sine 25 involves a square root. So I'm not going to use either of the cos double angle ratios that involves a sine, just because I don't really want to have to deal with the square root. Yes, they're going to be squared, and yes, it'll cancel out, and that's fine. So you're more than welcome to, but I'm just not going to. Like, there's no point in overcomplicating it. So I'm going to use the cos double angle 2 cos squared of 25 minus 1. That is the same thing as cos 50. It's just the expansion of the double angle. We know that cos 25, so just remember this is saying 2 times cos of 25 degrees squared minus 1. That is what cos squared 25 means. And we know that cos of 25 degrees is m. So we've got 2 times m squared minus 1. And that's it. All right. So be on the lookout, particularly in these types of questions, for your double angles. And always just choose the words here aren't wording. Choose the formula or choose the expansion that makes the most sense. Like I say, all of the others are absolutely fine if you want to use them, but I would just make my life as easy as possible. But all of the others are absolutely fine. Kanye, I do see your hand. Just quickly mark allocation, understanding the double angle, whatever that thing is, and then obviously your answer. Kanye?
Ma'am, I wanted to ask, is 25 a special angle? Because whenever I see without like a calculator, I always think you can only use special angles. So
okay, so that's fair. Generally, it does mean that. In this case, without the use of a calculator, is because of the fact that I'm writing everything in terms of m. So I'm not needing to do any calculations. I'm just writing in terms of a variable. However, with that being said, look out for special angles. So in question 3, look out for a special angle, because if you need to now work with compound angles and you need to expand using our compound angle rules, it has to be done without a calculator. So bear it in mind, but don't always assume that it has to be a special angle.
Oh, okay, ma'am. Thank you.
Okay, good. All right, so guys, this leads us into question 3, where we are being asked to find the ratio of cos 55, and I've kind of already given it away, but the hint, compound angles. If you need more of a hint, if you weren't listening, special angles. Now, Owami came up with an answer to a question like this on Monday, so let's see if we can come up with something here. How can we get cos 55 using the information that we have, so that 25 and 65? And if you're really struggling, think about a special angle you can introduce, because remember, special angles we know the ratios of. Okay, so have a think. Put some suggestions there in the chat. Nice. And then we'll have a see. That's Rattle. Right, so guys, again, if you get an angle, any angle, always double check, is it in the triangle? If it's not in the triangle, it means it's neither the angle you were given nor co-ratio. So we can move on from that. 55 is obviously not a double angle of 65 or 25. And so then we move on to our next option, which is a compound angle. Now, this is where, like I was saying now, we need to consider special angles, because we don't want to just introduce a random number. There are an infinite number of ways you can get the angle 55. You could say 5 plus 50. 15 plus 40. Like, there are so many ways that you can get it, but we want to use the information we have. And if we can't get the full sort of idea from that, then we need to introduce special angles. So like Lorato's put there on the chat, cos of 30 plus 25 gives us 55. And this is great because 30 is a special angle. So we know that ratio. And 25 is in my triangle, so I can use that ratio. And so what we now have is a compound angle situation, which we can expand. So this is a cos alpha plus beta situation. So we are looking at this expansion over here. Cos is the one where it's cos, cos, sine, sine, and then the opposite sign that you're using. So because this is plus 30 plus 25, in between my expansion will be a negative. So cos 30 times cos, sorry, that was a weird cos, 25 minus sine 30 times sine 25. And all of these we can now find the ratio for. Okay, Tills, I said this on Monday. I'm going to be honest, I don't know my special angles, not off by heart. Some of them kind of, but truthfully, no. Use a calculator. If in doubt and you don't know your special angles and you can't remember the triangles, just type it into your calculator. There's no point in not getting the marks because you've forgotten a silly thing like a special angle. What is important is that you show you're working out. Okay, so cos 30 is root 3 over 2 times cos 25, which we already know is m, minus sine 30 is a half, times sine 25, which we know is that horrible root 1 minus m squared. And now we go and simplify all of this. So root 3 times m over 2 minus root 1 minus m squared over 2. That's an LCD, so I can put it all into one fraction. All over 2. Okay, so it doesn't look nice, absolutely, but we have found the value of cos 55 degrees. So like I say, in these questions, you can expect a double angle somewhere and a compound angle. The co-ratio situation was more grade 11 concept. I'm not saying that the co-ratios can't come up. They definitely can, but you can 100% expect a double angle, compound angle situation. All right, this is a 3 marker. And this is because we had a fair amount that we needed to do here. So the first thing, or your first mark is the expansion using your double angle. That looks like exponent, expand. Substituting in your special angle ratios and your M ratios, and then your answer. Okay. Lorato, you could, but just remember 10 isn't a special angle. So now you're creating a situation where you can get the ratio of 65, but you don't know the ratio of 10. And it's not a double angle situation that you can work backwards. So that's what I'm saying. There's an infinite number of possibilities. We just need to try and work with the information that we have. Okay, so because 10 isn't in the triangle, nor is it a double angle or anything, it's just overcomplicating it. Cool. So let's take screenshots. Obviously, as I go, if you have questions, please ask. We got there in the end. All right. Let's have a look at this one. So question B asks us to simplify the following expression. And the expression that we have been given, is sine 21 times cos W plus cos 21 times sine W over sine W plus 21 minus tan squared beta times cos squared beta. Right, now this is only worth 3 marks, but with that being said, I'm going to give you 5 minutes to try this. Okay, now 5 minutes is a bit long, and I don't think you need 5 minutes, but there's a fair amount that we need to wrap our head around. So I'm going to give you 5 minutes to give this a try. What I am just going to do is just check our formulas here again for us. around. Just so that we do have them. And I want you to try this. So we're simplifying to a single term, which basically means sine, cos, or tan. One of them, nothing weird. And let's have a look. All right, so 5 minutes. Let's see how we go. Kazimla, you are close. And the only reason I know that is because I made exactly the same mistake. There should be another term there. So just go and have a look. There should be a term before that minus sine squared b term. So just have a look. Okay, so it seems we're all on the right track. So sorry. Seems we're all on the right track, so let's have a look. Okay, so if that's where I was going, but let's see. So First things first that we should notice is that that numerator is a compound angle situation. So it's sine cos plus cos sine. So we have this formula that we can apply here. So we can condense all of that to be sine 21 plus w all over sine w, excuse me, plus 21. Now remember, it doesn't matter the order in which you add things, it's the same term. So what we actually have here is the same term divided by the same term. So that'll simplify, but we'll deal with that now. The tan squared beta, I can write as sine squared beta over cos squared beta, and that is being multiplied by cos squared beta. So now we can start to simplify everything. This obviously simplifies. The cos beta and the cos beta simplifies. And so what we have, and I think this is what we've left, is 1 minus sine squared beta. So I initially forgot that 1. So just make sure you haven't. Because remember, x divided by x is 1. Now again, guys, there's more to this than just that. The question specifically said to a single term. This isn't a single term. This is 2 terms. And so we need to go back to like our grade 11 identities where we know that sine squared beta or sine squared x plus cos squared x equals 1. And one of the manipulations of that is the fact that cos squared x is equal to 1 minus sine squared x. And so this can then be simplified to that single term of cos squared beta. Weird looking beta, but anyways. All right, so I know I forgot the 1. That's where I went wrong. So just double check that. And then don't forget that it said a single term. 1 minus sine squared beta is 2 terms. So we need to make sure that we do actually simplify. Okay, so like I said, this was only 3 marks. So you get a mark for the tan identity switch. Essentially a simplification mark. So the fraction compound angle simplification situation, and then a mark for your final answer for that single simplified term. Alrighty, so like I said, this wasn't particularly hard, but there were just a few little places where we could have been tricked or caught out, and we just need to be careful. All right, so I'm just going to wait here for you to screenshot, and then we'll have a look at the next one. And obviously, guys, if you have questions, just ask as we go along. Okay. So this question I thought was quite cool because it's not what we expect, but again, it's not a hard question in any shape, sense, or form. So it says, in triangle ABC, it is given that AB equals AC equals 5 units and angle B equals 72. Sketch the triangle and then calculate the area. All right, so this is like a 2D trig, 3D trig problem, but it's made a little bit harder because you don't have the diagram. Often we have the diagram with our triangles. We can go from there and it's easy peasy. But this one we don't. So we just need to be mindful of that. Now, guys, what this triangle ends up looking like is whatever. But we know for a fact it's going to be an isosceles triangle, which that's not even a triangle. There we go. And we have triangle A, B, C. We start to fill in the information that we have. So AB is equal to AC. So AB is equal to AC. And angle B is equal to 72. So this angle up here, 72 degrees. We want the area. Now remember, there are 2 ways that you can find the area of a triangle. Half base times height, which you've been learning since primary school, or the area rule. Okay, this is on your formula sheet, so you don't need to learn it off by heart. But the area of a triangle using trig is equal to half AB times sine of angle C. Sorry, I don't know why my brain had a brain fart there. Again, it's on your formula sheet. There it is. Okay. Now, let's just understand what this rule is saying to us. And I said this to you on Monday. It's all very well knowing the rules, but if we don't understand how to apply it, that does become tricky. So the AB situation, these are two adjacent sides. So two sides that share a vertex, AB and AC, AB and BC, BC and AC, they must share a vertex. This angle over here will be the included angle. So we need to have two sides and the included angle. That's what we need. Whatever those two sides are, whatever the angle is, that's what we need. Okay. So if we go to our diagram, obviously we have the two sides AB and AC. That's great. So logic tells me I've got two adjacent sides. Let's just show that for ourselves. So we've got our two adjacent sides AB and AC, which means in order for me to apply this rule, I need the included angle. So I need to figure out what this angle at A is. Now that's easy, all right? Because this is an isosceles triangle, I know that the angle C is 72 degrees, angles opposite equal sides. And again, yes, you should give reasons because it's geometry. They're geometry. Put reasons. That's it. Right, so we know that this is 72 degrees as well, and then we can use sum of angles in a triangle to work out the angle A, or the size of angle A, and we get that A is 56 degrees. Okay, so this is 36. I now have all the information I need to go and work out my area because I have two adjacent sides and the angle in between. Right, so we just substitute in half 5 times 5 times sine of the angle in between them, so sine 36, and you type that into your calculator, and that gives you 7,35 units squared. Again, we're not super strict about you saying units squared. Sorry. Ooh. Anyways, we're not super strict about you saying units squared, but it is an area, you know that it's units squared. Just write units squared. Okay, so this was 4 marks. So getting the angle C, getting your angle A, substituting into your formula, getting your answer. All right, so again, not a hard question once we actually get into it, but it's just understanding that without a sketch, we do need to be able to visualize what's happening. Right, so let's screenshot this, and then we'll have a look. Barato?
Ma'am, if the formula is on the formula sheet, is it necessary to rewrite it as it is and then substitute, or can you just like move, like?
You can go straight into substitution.
Yes, ma'am. But then if it were to be the case whereby it's not on the formula sheet, then would they require us to write?
I'm trying to think of what formula you use that isn't on the formula sheet.
Like, ma'am, you know, for your is it optimization? Like maybe like you want volume.
Or like,
I should say,
okay.
your volume of surface areas.
No, I mean, you can write it, but no, we're more, so you'll get a mark for correct formula, but I don't necessarily need the formula without substitution. You can get the correct formula mark as well as your substitution mark. So if I can see you have substituted into the correct formula, you can get that mark. Okay, so guys, yeah, generally don't write the formula, but obviously if you want to, if that makes you more comfortable, absolutely. And like I say, where there are marks allocated to correct formula, if I can see you've substituted into the correct formula, you can get the mark there anyways. Okay, so let's have a look. Some trig functions, and this is some tree diagrams. Clearly. All right, so we have got in the diagram below the graphs of f of x equals 3 sine px and g of x equals 2 sine x have been drawn for the interval X element 0 to 360. Now remember, your graphs will always be labeled for you, so you don't need to and ah about which is which. And the reason for that is, remember, we've discussed this, a sine graph can become a cos graph can become a sine graph. So we do need to tell you which is which. So this yellow graph over here is your sine, is your f of x graph rather. My highlighting skills are really top notch. And then we have g of x, which is 2 sine x. Ooh, okay, you get the picture. All right, now guys, when you get trig functions, what's really important is that you analyze what is actually happening on the graph. So for example, f of x, we have been given the a value. So what I mean by that is we have been given what the coefficient is. We know it's 3, and we should know that that represents our amplitude. So if we go and have a look at our graph, we can see that our maximum is at 3, our minimum's at -3. So that corresponds with what information I've been given. Same for the graph of g of x. G of x, we were told, is 2 sine x. So again, this tells me about my amplitude. And if we go and have a look at our graph, we can see our maximum is at 2, our minimum is at -2. So that's the first thing we just want to kind of check. Next thing I want to check is, has anything else happened to my graphs? So f of x, I can clearly see still has a p, okay, in front of the x. Sine of x is just 2 sine x. There's nothing more happening here. So we need to also understand what this p does. Any coefficient to your angle, so any number in front of your angle that's been multiplied, affects the period of your graph. Now, the period of your graph is how quickly a cycle completes itself. We know that normally for a sine graph, the period is 360 degrees. But I can see very clearly here that I'm getting a repeated cycle for my sine graph. So I just need to bear that in mind. We now have a look at our questions. First question says, write down the value of p. So I said we've got a repeated cycle. Can anyone tell me what my p value is here? Give me your best guess. Nice, Mhlatsi. Exactly, 180 degrees. Right, so if we're not too sure why, let's have a look. So firstly, the blue graph. That's a normal sine graph with no period change. You can see it completes one cycle in 360 degrees. If we now look at our yellow graph, though, here's one complete cycle, and from 180, it now repeats its shape again. So I know I've got 2 cycles over 360 degrees. Now, there's a few ways you can go and work out this p-value. I'll give you a few formulas. But essentially what you're doing is you're looking at how many degrees your graph repeats itself, and you compare it to the original period. So our p-value here is 2. And one of the ways we can determine this is that p is equal to your original period divided by your new period. Oh, that's not how you spell period, is it? Period. Period. Oh, that's not how you spell it either. Period. There we go. Right, so if we take this, the original or normal sine graph with no manipulation has a period of 360 degrees. We can see now for this new graph, one cycle completes in 180 degrees. So that's my new period. 360 divided by 180 gives me 2. Okay, so you need to understand all of these manipulations of your functions so that when we give you a question like this, we can answer it. Now, a summary of all of these manipulations is on Google Classroom. So in that info pack, it's all there for you. But we need to understand what's happening to the period. And we can see that it's kind of been squished in comparison to the blue graph. So the cycle is repeating much faster. All right, question B then asks, what is the period of f of x? We've already answered that question. It's 180 degrees. You could still use this formula up here and just manipulate it. So for example, you now know that P is 2. You know that your original period is 360. You want to figure out the new period, and you can go and solve the equation from there if you wanted to. But realistically, if you know that your period is 2 for a sine or a cos graph, you should know that the period is 180. Right, so nice and easy, straightforward, nothing too stressful over there. 2 nice, easy marks, done and dusted. The next question now asks, write down the coordinates of B correct to 1 decimal digit. So B is, just highlight that for us, this coordinate over here. Can anyone tell me what's special about that coordinate on the graphs? Nice. Okay, Maflatsi, Lorato, very good. It's a point of intersection. Okay, so it's an intersection point between your two graphs. Now, unfortunately, we can't just go read off what the values are. They're decimal digits or decimal values. We can't do that. We're going to have to go work it out. And the fact that this is a 5-mark question gives me an idea that I'm going to have to do a fair amount of work. For any function, how do we find the point of intersection? What do we do? Nice. Okay, so for points of intersection, we make our equations equal to each other. So we equate f of x and g of x. All right, so that's what we want to do. We want to say f of x equals g of x. No, you don't have to write that down. You can go straight away into equating them. F of x was 3 sine px, and we know p is 2, so 3 sine 2x is equal to 2 sine x. And now, guys, this is a trig equation, a general solution situation. We are looking for a single coordinate for b, so we can kind of use that in our thinking when we get there, but we then need to be able to solve a general solution, find the general solution. All right, so in terms of general solution, there's a couple of things that we need to remember. If you have got two ratios, so here we've got the sine 2x and the sine x, there's a couple of things we want to check. Firstly, are the ratios the same? In this case, sine and sine, my ratios are the same. That's a good start. If they aren't the same, so let's say you had a sine and a cos, what we then want to check are the angles. So if, for example, you had sine 2x equals, I don't know, 2 cos 2x. Because these angles are the same, we can create tan. If we divide both sides by cos 2x, sine 2x divided by cos 2x is tan 2x. And then we've got an equation we can go and solve. If these angles are not the same, we're going to have to explore co-ratios and more complex sort of situations. And generally speaking, that is what's going to happen, particularly in functions. So if, let's say, for example, this was sine x equals, I don't know, cos 3x, we would then have to use a co-ratio here. Don't know why I made the choice to go 3x. It's a weird one. But anyways, we would use a co-ratio. So I would say sine x is equal to sine of 90 minus 3x. That gives me cos 3x. And at least now my ratios are the same and I can go and solve. So those are just some things to bear in mind as we start to move into our general solution. Okay, we'll leave that there. Right, but however, this one is great. My ratios are the same. The problem I have here are that my angles are not the same. So I've got an x angle and I've got a 2x angle. It's not the end of the world, but ideally our angles need to be the same. Okay? So if we now go and have a look, I'm not going to use a co-ratio here because I don't want to introduce a cos. I need to get these angles to both be x. And because this is a sine 2x, this is a double angle situation. So we can expand this. The sine double angle is 2 sine x times cos x is equal to 2 sine x. And at least, sorry. Okay, I closed it for myself, not for you. And at least now what we have is a situation where my angles are the same. All right. From this point, I now need to try and figure out how to solve this equation. So let's just simplify what we have on the left. This is 6 sine x cos x equals 2 sine x. Now, this is not great. This is not what I want. So let's think logically about this. If I were to compare these two terms, one thing I should notice is the fact that both of these terms have a sine x in them. It's a common factor between the two. So if I now go back to my factorization knowledge, if I bring that 2 sine x over and make it negative 2 sine x equals 0, I can now go and factorize. So first thing I'm going to do is I'm just going to divide everything by 2 because that's a common factor. You can take it out as a common factor as well if you want, but I've got 3 sine x cos x minus sine x. Now I'm going to factorize by taking out sine x as my common factor, leaving me with 3 cos x minus 1. And this is now a quadratic equation. We know how to solve quadratic equations. We take each of these factors, so the sine x equals 0, or the 3 cos x minus 1 equals 0. And now we can solve these equations. All right, now obviously we need to think logically about this because you don't really want to do extra work if we don't need to. Now, grade 12s, what I do want to say to you is that there are lots of different ways to solve a trig equation. My method that I use is reference angles. That's not the only way to do it, but I do find that if you struggle with general solution, reference angles is a slightly easier way to do it because there's steps that you follow and you just follow those steps. All right, so if I just look at the sine of x situation, if I were to go and work out my reference angle, which I do by saying shift sine of whatever this ratio is, but I ignore what the sine of my ratio is. So if this had been sine x equals negative a half, I would say shift sine a half, ignore the negative, and I will use the negative to then decide on my quadrants later. But because this is 0, 0, 0, there's no sign attached to it, we can go and just say shift sine 0. Shift sine 0. So shift sine 0 is 0 degrees, which means we're in quadrant 1 to start off with. And so x is equal to 0 plus k times 360. K is an integer. Now, guys, think about this logically, right? If we're at 0 degrees, so here we are at 0 degrees. If I add 360, I'm going all the way to the end of my Cartesian plane. Okay, so here I am at 0 degrees. Plus k times 360, there's a 360. I'm not getting anywhere near the solution of b. Okay, this is not a solution that is helpful to me. So if you realize that, oh, goodness gracious. If you realize that, and you realize that working with this equation, sine of x equals 0 is pointless, awesome. You can then ignore it. If you don't realize it, it's not the end of the world. It's not a hard equation to go and solve. You will find that it's not useful to you. What is useful to us, though, is the second equation. So that 3 cos x minus 1. So when we solve a trig equation, first thing we want to do is we want to isolate our trig ratio. So we want to get this cos x alone. That means I'm going to have to add 1 to both sides and then divide by 3. So cos of x is equal to a third. I work out my reference angle. So I say shift cos of a third. And that gives me a reference angle of 70,53 degrees. Now I go back and check the sign of my ratio. So this was a positive, a third, and I'm now going to use that to figure out which quadrants I'm working in. So I need to know where is cos positive. Cos is positive in quadrant 1 and 3. So that's where my solutions will exist for this trig equation. So quadrant 1 solution, x equals just the angle 70,53 degrees plus k times 360, where k is an element of the integer number system. And for quadrant 4, we now apply our reduction. So in quadrant 4, our reduction is 360 minus our reference angle plus k times 360, all of that fun stuff. And what we get when we say 360 minus is 289.47 degrees. And if we go back to look at where B is at the 287.4. If you were to read up, that's about 287.4. So we can get our X value. And then all we do to get our Y value is we substitute this angle into either one of our equations. So either we can say 3 sine 2 times 289.47 for f of x, or you can use your g of x equation, which is 2 sine times 289.47, and you will get your corresponding y value, which ends up being as like negative 1.89. And so we get our coordinate for B. Right, so there's a fair amount of working out, but this was a 5-mark question. Okay, generally this is where general solution pops up in functions where we're looking for points of intersection. And so it's just important to be mindful of that and just kind of bear in mind the little pieces of information I gave you, when to use co-ratios, when to use tan, etc. All right, so just mark allocation here for you. Getting the double angle expansion, factorizing appropriately. Because this isn't a solution that really is relevant to us, there's no marks allocated for that, but you do get marks allocated here for isolating your cos ratio, getting your solution, and then substituting back to get your y. So those are your 5 marks that we're working with. Okay, so just because I don't want to leave anything out, let's take a screenshot of those first 2 questions, and then I'll come back to C for you to screenshot. Kazimla, what did you do out of interest if you didn't factorize? Okay, I'm scrolling down to C for you to screenshot. I just can't see another way to do it without factorizing. What did you divide both sides by? Okay, so you divided both sides by sine x. Right, so we can't do that because what we need to bear in mind is that sine x is one of our solutions. Even though we don't end up using that solution, we can't just ignore the fact that that solution exists. We never want to divide by an unknown unless it's the case where we're creating tan, because tan contains the sine and the cos. So we're not getting rid of anything, we're just manipulating it. But we cannot divide away a ratio because then we're ignoring one of the potential solutions. Does that make sense? Kazimla, we good? Okay, perfect. Sorry, I see now. All right, so guys, just be mindful. We don't want to divide away ratios because then we're ignoring a solution, and we don't want to do that. Perfect. All right, question D says, if k is a positive real number, then for what values of k will f of x equals k have no real solutions? Okay, so this is a fun one. Again, I know that these questions aren't necessarily our favorites. I'll be honest, I hate K questions. Whenever I see a K question, I'm just like, nope. But let's have a C. All right, so I'm just putting the graphs here again so we can have a look at what we're dealing with. Right. So first things first, we're dealing with f of x. So f of x was this graph over here. Not my best graph I've ever drawn in the world, but you get it. Now, what we need to remember, grade 12s, and this is, I think, where we get a bit tripped up. We don't always remember what k represents. K is a constant. And so what that means is if you add or subtract a constant, so let's say, for example, you had the 3 sine 2x plus 1. That is a constant, and that means a shift up or down. Okay? So the shift up or down is what k represents. Right, so I'll see your question. I'll come back to it in a second. Let me just do this one. So this k is a shift up or a shift down and we now need to go and shift it appropriately to get whatever we want. And so in this case, we've been told that we want no real solutions. So what does that mean? Well, no real solutions means no x-intercepts. We don't want this graph to cut the x-intercept anywhere. Now, bear in mind that the maximum value we have here is 3 on my graph, the minimum -3. But realistically, what we actually want to do here is we want to take this graph and we want to move it all the way down so that it sits past the x-axis. Because if I move it down here, there's no x-intercepts, so there's no real solutions. And essentially what that means is I need to get these two maximum points below my x-axis. And so what that means is I need to move at least, no, not at least, just more than 3 units down, because 3 units down takes me onto the x-axis, which I don't want. I don't want intercepts. I need to go just more than 3 units down in order for me to get no real solutions. Okay, so let's figure out what that means in terms of our value of k. So f of x was the 3 sine 2x equals k. And remember, we want this k to be part of my equation. So if I bring that over, I've got 3 sine 2x minus k. And that would then be my f of x graph, or whatever graph I'm talking about. So we need to figure out how many units I'm moving down. Well, I need to move down at least 3 units. And so what that means is that k must be greater than 3. So let's just figure out why. If you substitute in a value greater than 3, so let's say k equals 4. If I substitute that into my equation, when I substitute in a positive 4, that negative makes it a -4. So 3 sine 2x minus 4, 4 units down. If I were to substitute in k equals 7, it would be 7 units down, which is still fine with us. So we just need to bear in mind what sign we should be working with in order for our shift up or down to then occur. All right, so again, we want no real roots, which means those turning points need to go down below the x-axis, and so we need to go more than 3 units down. Right. I'm just going to wait here for a screenshot, and then I'll go back up. Rato, I'm not entirely sure if I actually understand your question, but let me go back up to the question, and then hopefully we can figure it out. All right, so why didn't I distribute the 3? I did distribute the 3. The only place I can see that is here. So I did. I said 3 times 2, and that gave me the 6. There's nowhere else I can distribute. Just let me know. But I did. I did.
Oh, so ma'am, you didn't say the 3 times cos x.
Oh, remember, this is one term.
Oh, yeah.
So okay. if that had been a plus, then yes, I would. But it's not. It's a times. So I'm just multiplying once.
Okay. Thank you, ma'am.
Okay. Pleasure. Right. I'm just going to back a bit. Yeah. Here, in case you want to still screenshot. And then I'm going to move to question 5. The next paper. Kanye, I do also see your question. Absolutely. Is it on the Google Classroom? Just because I didn't see anything there, but obviously, so when I say, is it on the Google Classroom, did you upload it onto the Google Classroom for me to have a look at? If not, we can definitely have a look just now. Virato?
Ma'am, I just have another question with the question we just did. So how would it exactly apply because ma'am, the minimum value is like -3. So would it be advisable to also visit it, or usually just stick to the maximum number when they ask such questions?
Yeah, no, sorry, I see what you're saying. Yes, we could also move the graph up. Jeez, I'm like in my own world here. So guys, yeah, we absolutely could also move the graph up in order to get no real roots. So k must be greater than 3, but k must also be less than -3. So again, if we figure out why that is, if we go less than 3, so k equals -4. If I substitute that in, a negative times a negative is a positive, 4 units up. So that'll bring my turning points above. Yeah, sorry, I completely forgot about the second situation. I don't know why we always forget about that second situation. Connie?
Ma'am, can I share my screen? Because I don't know how to upload.
Sure.
Okay. Ma'am, can you see it?
I can. Let me just write this down.
This is the question.
Cos 2x, okay. Cool. Cool, thank you. Yes, sorry. So guys, geez, it also helps to read a question. Exactly, Kazimla. So it does say if k is a positive real number, so yes, it would only be the k greater than 0, but just bear in mind there are 2 ways to do it. So think about this, but yes, in this case, if we read the question and remembered positive, it's just that one. Thank you for being attentive. Okay, so if we have a quick look at this, sorry. Can you still see my screen, guys? Because I can't see my screen. Please ignore me. You should all be able to see my screen now. Okay, so if we have a quick look at this general solution here, I'm just going to go on the side. So we've got cos 2x equals cos x. Okay, so like I said, check a few things. The ratios are the same. Great. The ratios are the same. The angles are different, which is not an ideal situation, but we don't necessarily need to change it. So we're not going to use a co-ratio because that's not productive. It's then introducing sine. I don't want that. We're not going to necessarily do compound angles or anything like that. We don't need to. So the way we deal with something like this is our reference angle is no longer a number. So you can do it on either side. I always just take my reference angle to be the number or the angle on the right. Okay, my brain works left to right, so I just take it like that. So I say, cool, my reference angle is x. This ratio that I'm working with from my reference angle is positive. It's positive cos x. And so again, I move to my quadrants. I'm then looking at quadrants 1 and 4 for a positive cos ratio. Cool. So quadrant 1, I take the angle I'm solving for, 2x, is equal to my reference angle plus k times 360, blah, blah, blah. And then I solve. So I would use my inverse operation, subtract x on both sides. X is equal to 0 plus k times 360. K is an integer. Okay, so that's my first solution. My quadrant 4 solution, again, I take the angle I'm solving for, 2x, and I apply the reduction that is appropriate here, which would be 360 minus x plus k times 360. K is an integer. And then again, I solve. So now I'm going to add x on both sides. So I get 3x is equal to 360 plus k times 360, where k is an integer. I want x alone, so I divide everything by 3. X is equal to 120 plus k times 120, where k is an integer. That took a turn anyways. All right, so when you have the angles like that, you don't necessarily have to find a numerical reference angle. Your reference angle can be a variable. And like I say, I always just work with my reference angle on the right-hand side. It's just easier for me. And then we just go and solve like that. Okay, so Connie, I hope that makes sense. Do you remember how many marks this question was out of? I would say probably like 4 or 5. 6 marks. Okay. It's quite generous. Okay, so you definitely get a mark for your solution. Sometimes we give you a mark for, particularly like over here where you've had to divide, we'll give you a mark for the k times 120, so adding the correct period. Quadrant 1, so getting the 0, quadrant 2, the 120, that's 5 marks. The only other like 6 mark I can imagine would be the reduction. So applying the appropriate reduction in quadrant 4. So yeah, 6 marks. No problem. That was actually a really nice general solution question to show what I was talking about earlier. So thanks for bringing it up. Okay, guys. So what we have here is a lovely Cartesian plane question. And I want you guys to try it. There is a question for, I don't want to make it too small, sorry. Okay, just tell me if that's too small. If it's too small, just say so. It is too small. Okay, fair enough. Let's just do this. All right, zero. All right, so this first question, 11 marks. I'm going to give you 11 minutes. I want you to answer 511 to 514 for me. So it says, in the diagram below, P is at 3, 4, and R is at M negative 12 are 2 points as indicated. Angle POW is alpha and ROW is beta. So the reflex angle. And then you have to go and work out a bunch of ratios. Okay, so 11 minutes. Let's go. Obviously, as you go along, if you have questions, just ask, or if you want to put answers in the chat, that's cool. But let's try. All right, grade 12s. So again, if you're not done, don't stress, but it is a good way for you to kind of gauge whether or not you are managing your time appropriately. All right. So let's have a look. In this case, we do actually have a diagram, which is great. I don't have to draw any diagrams. We're sorted. So it says write down the value of tan alpha. Now remember, tan on your Cartesian plane is y over x. And because you have the x and the y coordinate, you don't actually need to do anything. It's quite literally, 4 over 3. That's it. Right, 512 says determine the value of sine 90 plus alpha. Now immediately alarm bell should be going off that this is a reduction, not a co-ratio. So quickly, as a quick recap, sine 90 plus is quadrant 2. This is where sine is positive. So this co-ratio becomes just positive cos alpha. Now again, cos alpha, or cos on your Cartesian plane, is x over r. I have x, I don't have r. So we would need to go and figure out what this r value is here. Now we should kind of know what this is, but if we don't, r squared is equal to 3 squared plus 4 squared. We just use Pythagoras. But this is a 3, 4, 5 triple, so r is equal to 5. And so therefore, cos alpha is equal to 3 over 5, x over r. So this is why this question is worth so many marks, because you have to do the Pythagoras calculation. 513 says determine the value of m if it is given that 12 plus 13 sine beta equals 0. Okay, so firstly, where's m? Well, m is the x coordinate over here. So essentially what we kind of want to try and do here is we want to try and get the sine beta alone, because sine beta on your Cartesian plane is y over r. And so once we know what this r value is, we can once again use Pythagoras to go and find m. So we want to isolate sine beta. So that means I've got 13 sine beta is equal to negative 12. Dividing both sides by 13, I get negative 12 over 13. Lovely. This is y over r. We can already clearly see that negative 12 is y, because that was given to us as our y coordinate. And we can now use this information to go and perform Pythagoras. So m squared would be equal to your r squared, which is 13, minus your y squared, which is negative 12 squared. And that gives me an m value of plus or minus 5. Remember, when we square root something, plus or minus, I didn't do that here for r because I know r is always positive. Now I have to decide, should this x value be positive or negative? Well, if we go and have a look at where it would be on the x-axis, that's a negative x. So that therefore means that my coordinate of m is negative 5. Okay, so always just use your diagram as a reference point. Check if it makes sense according to what you've done. Right, and then the last question says, determine the value of cos alpha plus beta. Sorry. So cos alpha plus beta, those are two different angles that I have here. And so what this means is I'm going to have to expand using compound angles. So my expansion is cos alpha times cos beta minus sine alpha. Sorry, that's a terrible looking beta, but anyways, sine alpha times sine beta. And now we can go and read all of those ratios off of our diagram. I don't need to do anything more than that because I actually have all the information I need. So cos alpha, I already have 3 over 5. Cos beta, I read off from my diagram. It would be the negative 5 over 13. Minus sine alpha, we don't have, but we can just read it off. It is 4 over 5. Times sine beta, we isolated it up here, negative 12 over 13. Right, now, again, it says to me without the use of a calculator, however, grade 12s, like, you know, do you? So show you're working out. Use a calculator, but show you're working out. So what I mean by that is times each of these fractions together. Oh, sorry, it feels like there's something crawling on my head, and I'm not about that today. So just use your calculator to times the fractions. Just show each of your steps. So when we multiply those first two fractions together, I get -3/13. Multiply the second two, plus 48/65. You could go show your LCD here, but missions, just type it into your calculator. 33/65 is your final answer. What we are more concerned about here is your compound angle expansion and your substitution, not really the without a calculator situation. So 1 mark up here, 3 marks, 1 mark for your Pythagoras calculation up at the top, 1 mark for your reduction, 1 mark for your answer. The 4 marks in 513 is for the standard form, so isolating your sine beta. The Pythagoras calculation, essentially understanding how to simplify and getting the appropriate negative answer for m. And then your last question is the compound angle expansion, the substitution, and your answer. Like I say, we're not like super concerned about the working out here. So when in doubt, rather use your calculator so you are actually getting the answers. If you feel very strongly, you would have to be finding LCDs and you'd have to be multiplying your fractions appropriately. All right, but guys, that's 11 marks. That's what? 20% of your trig marks answered. Nice and easy Cartesian plane question. Alrighty, so hopefully we're not feeling too stressed about trig. Hopefully, fingers crossed. Keep practicing. There are so many past papers available to you, and I've got all the links. All the links are on the Google Classroom. Use them. And obviously, again, if you have questions, upload them onto the Google Classroom or ask me, and we can have a look. All right, guys. So I'm just going to wait there for you to screenshot. It is 7:02, so if you need to go, that's absolutely fine. No hard feelings. I will see you on Monday next week, where we're going to finish off with Euclidean geometry, and then you write on Friday, and then Monday, you're done. You've got this. All right, so I will see you on Monday. Just waiting for those last screenshots, and have an awesome rest of your week.